This time, let's find the derivative of the given rational function. A complex function identified as f of z is equal to 1 plus z all over 1 minus z. But this time, we're going to use the definition. The definition for a derivative of a complex function is equivalent to, okay, this one here, derivative f of z is equal to the limit of your f of z plus delta z minus f of z all over delta z as delta z approaches 0. If the limit exists, then the derivative exists for this portion. But of course, as delta z approaches 0, this will be undefined. Hence, we'll be applying some mathematical operations later on in order for us to simply vary that further. Take that our given function is a rational function, and we have two versions of that here. We have this, which is originally what is written, but this one is a transformation using z plus delta z instead of z. So allow me to use the scratch portion here at the bottom so that we can actually predict what is this first. So we are going to show the equivalent value for f of z plus delta z, where f of z is identified as a rational function 1 plus, okay, 1 plus z over 1 minus z. At this time, we're just simply going to change the z's here by this value and hopefully simplify it further. Okay, so let's try to show that here. It will be equivalent to 1 plus z. Let me place it here, denominator, because there might be some other processes. So you have 1 plus your z becomes z plus delta z all over 1 minus your z becomes z plus delta z. By simplifying that or removing the grouping symbol, we'll have here 1 plus z plus delta z all over 1, distributing negative sign, minus z and minus delta z. Okay, so this is the equivalent form for this. We can no longer simplify that because they are, of course, dissimilar terms. So let's stick to that as what we're going to apply in our original or the definition for a derivative. So we'll have here the form is equivalent now to the limit of your, let me use here delta z first as approaches 0, because our given function of z plus delta z is this entire form. It's a rational expression as part of the numerator. So you will have here 1 plus z plus delta z minus all over 1 minus z minus delta z, right? This form. Let me recheck if that is again correct. Okay, so pluses and signs, and in minus, rather, at the denominator. Minus, take note of this, we still have that 1 plus z over 1 minus z all over, we still have this as well. Don't forget all the parts. And with this, no matter how difficult of the numerator is or complicated that would be, we still need to simplify this because that would be approaching 0. So what we can do here is only, or first rather, to simplify our numerator, we're going to combine them by looking for LCD. Okay? So, allow me to use another part of the scratch below because this might be very complicated to look at when combining with the limit and this denominator. Let me just have the numerator itself and combine it with the second term, place it on this portion here. Again, we will have 1 plus z plus delta z. It will not hurt us to use a scratch paper, by the way, just to make sure that we will have proper steps. So 1 minus z. For the LCD, take note, this is another expression. That's also another expression here. So let's just combine them into one form. You have 1 minus z minus delta z. Let's not multiply them. Let's just stick to them in the meantime. Okay, stick to that in the meantime. So we'll have here LCD. So you'll be multiplying the numerator with 1 minus z for your original numerator. Okay, this is now the very taxing part, right? Minus, you have 1 plus z. So let me move it here because I still need to add here this one as a product of a factor on our second term, a numerator of the second term, because okay, we need to have the proper steps. Now, For this now, okay, looking into this perspective, let's simply continue. Allow me to transfer all of this here, by the way. Okay, hopefully it's okay with all of us, because we might need some spaces, a lot of spaces here. So what needs to be done here next is to really do it step by step. So for our numerator product, okay, so you're multiplying that. Hopefully you will follow me. I'm going to multiply all the first terms first before the second term, right? Distributive property, similar here, but retaining the subtraction. So you have 1 times z is z, 1 times delta z is delta z, then z times 1 is negative z, negative z times z is negative z squared. You have negative z delta z minus the second one. I'm treating this as minus still. I'm not going to distribute that. I will be distributing that later. So 1 times 1 here is 1. 1 times negative z is negative z. Then you have your minus delta z as well. Then multiplying this, z times 1 is z, and z times negative z is negative z squared, and we have minus z delta z. Take note, I did this all of them in this scratch, because if I stick it here, of course our problem is we will have a very complicated expression. So allow us to do this here step by step. Now, for this also, okay, we can also multiply now our denominator. So 1 times 1. I'll be distributing that here, okay, doing the left distribution. So 1 times z is minus z, minus delta z here as well. For our second term is minus z, this one here. And then you will have plus z squared, and you have plus z delta z. Okay, now next here is to distribute now the negative sign, or you can do this one. I can cancel this already. That's z minus z, right? That's the first thing I can cancel. The second here, I can also cancel this one here, so that later on I will have fewer number of terms. So you have 1 plus delta z minus z squared, then minus, by the way, on the denominator as well, you will have here z times z squared. Sorry for that, step by step. Alright, so I can actually combine this two later on our denominator. So we have minus z delta z, distributing that, minus 1. Okay, this one here, plus delta z. Okay, this one here, so plus z squared, and this one here is plus z delta z, all over our entire denominator. 1 minus 2z. Okay, you have this 2, right? Then we have here minus delta z and plus z squared plus z delta z. Now let us find out if we can combine some of them. Looking at our numerator and denominator, I'm talking about this one here. 1 minus 1. Minus z squared plus z squared. Minus z delta z and plus here. So what remains in our numerator will be this and that. So we will have here twice delta z over the same denominator, 1 minus twice z minus delta z. Let us check the denominator if there are other terms that we can combine. So obviously there are none. So just continue here, plus z squared plus z delta z. By the way, take note, this is not the final form to be implemented under the limit as delta z approaches 0. This is just the numerator. Take note of that. That is just the numerator. So allow us to place that here now. So we have here the limit still of your delta z as it approaches 0. Allow me to move this out. Okay? Take note that if I'm going to move that out, because my numerator is a rational expression, to make it easier, take note this is just equivalent to, let's say that just like this one. I'm going to give you one example. 1/2 over 3. We know that we are going to use the keep change flip method, right? So 1/2 times the reciprocal of 3 is 1/3. But obviously, This is just a 1/3 of 1/2. So this is, of course, 1/2 times this one here, 1/3, right? So 1/3, or again, the keep change flip method. My point here is, I have delta z, I just take it out. This is because my numerator is a rational expression. To make it easier for me, this is what will happen here. Instead of having nested rational expressions, that's a term, this is nested rational expressions. Instead of having that, I'm gonna copy the answer earlier, twice delta z, right? Twice delta z all over 1 minus 2z, 1 minus 2z, okay, minus delta z, sorry for that, plus z squared if I'm correct, and finally you have plus z delta z. So plus z delta z. But I'm not going to place here delta z just like this one here, because later on I'm going to still use the keep change flip method. And what I would like to do is to take that out. Again, the point here is just like 1/3 here. I'm going to take that out. That's automatically times 1 over delta z here. Or again, when you use keep change flip method, basically, instead of division, changes to multiplication and the reciprocal of that, we use just the same as this. But I have that simpler step, because when you look into this one, I can now cancel this and that there, leaving our denominator will no longer taking a sole delta z value just like this one. Because if we have delta z here, as delta z approaches 0, the entire expression is undefined, the limit doesn't exist, and the derivative, therefore, will not exist. But if you're going to cancel that, definitely, you will no longer have a delta z as a factor of your denominator. But you would see there's still delta z here, but since they are under a series of operation, we are guaranteed that our denominator will no longer be equal to 0. And that's the point here. As I continue the limit as delta z approaches 0, I have here 2 over 1 minus 2z minus delta z plus z squared plus z delta z, right? Because this is the only item that we have canceled. Again, as mentioned, even if it has delta z here, as you substitute 0, it will no longer be undefined, because all of the terms here are not zeros, or all other terms. Therefore, applying the limit now, this equivalent to, let me write your equality here earlier. So applying that, you will have 2 over 1 minus 2z, because it's only delta z that will approach 0, minus 0 plus z squared and plus 0, because that's 0 here. So basically your final answer is 2 over 1 minus twice z plus z squared. This is the limit. This is the limit as z delta z approaches 0, but basically that's the derivative of the given function 1 plus z over 1 minus z. If you're going to use the rule of differentiation, especially for quotient, we know that there is a rule on differentiation for that. You can try that on your own. I believe you should get the same result here, just that this denominator will not be expressed as a trinomial, probably a square or a binomial expression. Try that on your own, but I'm sure that this is now the final answer, considering all of these scribbles that we did here at the bottom. Again, the purpose of all of this is that our step here for the limit will not be very difficult to look at. We solve first this, which is equivalent to that one, and basically when you combine the entire numerator, it's just this form here. And again, taking out delta z as 1 over delta c, so you will have all of this at once. Thank you very much for watching.